Hello and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and the encouragement that you need to become energy independent and energy resilient. Today, moving forward in our sequence of energy storage systems, we're on to commercial and industrial energy storage systems. So with these systems, they're usually very large in scale. They range from around 100 kilowatt to can be a few megawatt power to support large loads for heavy industrial. Those systems can be dedicated to that facility for time of use where you're moving energy from solar and then deploying it. So you get the solar during the day. It's usually 9 a.m. to 4 or 5 p.m. that you're getting solar, and you can store all that energy on site and then deploy it in the evening to cover all the loads in the evening. Or you can use it for peak demand mitigation. So that would be where you are watching the loads coming in to the building, and when several machines come on at the same time or a large portion of the facility comes on, there will be a large demand increase. And commonly in industrial, it is for a limited amount of time. So maybe for half an hour, 45 minutes, for a couple hours, just for one process, if it's a heating process. And the energy storage system can use the energy that it has to reduce the load that the utility sees. So it will charge the system when the load on the building is low, and then it will discharge the system into your loads, making it so that your utility usage is more flat. What that usually does is it reduces your peak demand charge. So there's charges where they just charge you for how much power you use for a short amount of time. It's usually for around 15 minutes. And so if you're able to store enough energy to export all of the power required during a peak event and to keep that power usage low, then you'll save that difference in power. Some of the ranges for that would be, in my area, it's around $10 per kilowatt. And then in more extreme areas, they'll have $50 per kilowatt demand charge on commercial facilities. So those are some of the on-site things you can do with energy storage at your building if you have a commercial or industrial building. And then in addition to that, you can do solar, where you're just capturing solar into the battery and covering your load directly 24/7. So if you have enough energy storage and enough solar, it will fill the battery and be able to cover the loads for the full duration of the solar. And then throughout the night, your battery will be able to cover the rest of the loads. So it's self-consumption, you're generating on site and using all of the solar energy on site. The old or more traditional way to do solar was that you would put on a solar array and it would just turn on and export the power immediately when it was generated. That adds stress to the grid when the amount of power is significant. So if there's 50% of the power in the region generated from solar, then you're creating this very low power requirement in the middle of the day, and you're making a high power requirement during the evening and the morning and throughout the night, just because your power generation from solar is driving down the power. And so with that condition, a lot of power companies are trying to avoid that. And so they are reducing the amount of solar you can export, or at least giving you less credit. So you're disincentivized to export the power immediately. So one of the programs with that is the NEM 3.0 in California. They're doing less and less net metering and kind of driving it for more energy storage. Usually battery energy storage is what people use, but there are other options like flywheels for data centers, and also hydrogen production, where you can create hydrogen with your solar to use it in different applications. But those are kind of the in-house options for saving money and being able to add the resilience and the energy independence in your commercial building. The outside options would be to get enrolled in a demand energy response program with your utility. So a lot of utilities are starting preliminary programs for this. Some utilities have it in full force. I believe in Connecticut and New York there are some systems that are online now for demand response. Also for frequency regulation, there's a lot of systems in America that can get unstable when the power gets too high. And so some things that can do that would be kind of low head hydro. So if there's a small pressure difference on a hydro generation plant, like 10 or 12 or 15 feet of head, that's the pressure on the turbine, they can be unstable when supplying loads directly. But if they are just augmenting the grid, then it's fine. They can just inject power to the grid and they will stay stable. And so different systems like that can get a little bit out of whack on the frequency, and so there's some demand response programs where you can just inject power into the grid for a specific duration. It's usually the high power time of the day, so it's essentially the same as peak shaving, but it is for a different condition. And so if there isn't instability in the frequency, then they won't ask your system to provide power. But in that system, your system is just injecting power to reduce loads on the generation facilities to allow them to stabilize the frequency. So there's several programs like that, but if you sign up for those, sometimes you can get a free battery or get some of your battery paid for, or they will just pay you by the kilowatt power that's available to them. So if you have a megawatt, that would be 1,000 kilowatts power available to them for their demand response. So that could be for peak. So in the case of the recent events with Texas and the heat dome, the utilities can command and use batteries in industrial settings to cover the peak loads for the whole region, whatever's available. So they can just turn on all the batteries. If there's a lot, that can stabilize it. In other cases, there's insufficient and that wouldn't stabilize it fully. But I believe I did read an article about the Texas heat dome, and they are using some large batteries to augment some coal-fired power plants that were having issues at the peak load. So they're just injecting power at the same site with battery systems. And that's really a huge benefit of battery systems. They are instantaneously able to ramp up their power. So it's not instantaneous, but within a few seconds they can get to full power, and they can go pretty much as extreme as you ask them to inject the power. Whereas if you have a coal-fired plant or a natural gas-fired steam turbine plant, there's thermal capacitance of the water in the facility. So if it's not up to speed and ready to produce the steam, there is a long heating period. So if you're running all your burners, in the case of natural gas, it'll take 24 hours for that power plant to spin up to get enough heat into the water so that they can flash it and use the steam turbine. So it is a spinning facility, so it is ready to go on somewhat short order in the case of the coal-powered fire plant or the natural gas, but batteries can be within a few seconds. If you just have a simple turbine, then that will usually be able to activate in a couple hours. It just depends on what it requires. So a lot of them require high pressure natural gas, and so you have to turn on compressors and get everything up to pressure and then start your simple cycle gas turbine. So they can start up in a couple hours. The steam versions take about a day if they're not already at temperature. Batteries, on the other hand, can take milliseconds to activate and start providing power. And so to the utility, that's very helpful because they can just call for things. They don't have to plan it 2 days in advance and say, hey, start heating up your water in your coal-fired plant. We need you up and running by such and such day. They can just use an electronic signal and say, hey, I need power. Give me 100 megawatt, immediately. So right now or within 15 minutes. Some of these programs are already running and they have time periods like that. So the battery systems will be called to start within like 15-minute time frame. And so they'll get everything commanded and online, and then they'll all turn on and add the power to stabilize the frequency or to peak shave whatever's going on with the utility. But so those are a couple of the options. So it's pretty common where you can justify getting an energy storage system for your commercial building or your industrial building, where you do have high peak demand charges or where you have expensive energy. So Hawaii, a lot of islands, stuff like that, anyone that's doing diesel generation, it's usually justifiable to do an energy storage system at the current prices, because the price difference is enough to justify the system. So thank you guys for watching. I just want to encourage you guys that if you have businesses and they need power and you need uptime with that power, then battery energy storage systems are an excellent way to go. In addition to that, doing solar and self-consuming your power can be excellent if you're wanting to help the grid and to help the environment to reduce emissions. That's amazing as well. And then this is all just about us taking control of our lives and being independent and able to help other people. And this is an excellent opportunity where people can invest and support their local grid to help them stabilize and to just make the whole system more robust. So thank you guys for jumping on and watching. We'll talk to you guys later. Please like, subscribe, and share with people that you believe are interested. We're excited to get the word out. Thank you guys. Have a great day.